So it is 262 ohms. That's not good. It must be 400 ohms. Let's check between the white and the red. So it is 398 ohms. So this is our input terminal. If we check between the other two wires, it is 350 ohms. So these are the output wires. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. While working on this weight machine, this is 40 kg weight scale. When I replaced this load cell, I gained a very strange experience. The original load cell here, 40 kg, that was black wire here, that is negative excitation, and positive wire here, red wire here. In this connection, outside connection, that is positive excitation, signal low and signal high. But this load cell, when I replaced it, it gave me some amazing experience. Normally we see red wire is positive excitation, black wire is negative excitation. This is signal negative, signal positive. When we check its resistance, how we can test it, set to ohms. If we check the resistance between the black and red, it gives us 262 ohms. That is very strange. It must be around 400 plus minus 10 ohm plus minus 5 ohms. Okay. If we check the output resistance, yes, this is positive, this is negative. This is 311 ohm. It must be 350 ohms. When I connect it to the board, let me connect and I will show you what happened with me. This is the positive signal. How we can determine the positive signal? Check voltage between the outer two terminals. It is 3.3 volt. This 3.3 volt are coming from this 7533 IC voltage regulator, 3.3 regulator. So this 3.3 volt are excitation voltage for load cell. So we need to connect red wire at the outer terminal and black wire okay. Now I connected 3.3 volt. The voltage dropped here. Why? Because it is drawing over current. It is very strange. Let me remove it. If we check voltage, the voltage are present. And if we want to test what is the input terminal, connect one input probe in voltage mod and connect to the input lead. Any input terminal here, the display will not move. So connect here, it is moving. This is signal input. This is signal input. And this one is ground. Now let's verify the pins. How we can determine what is the input pin, which is the output pin. If we test between the positive red and black resistance, so it is 262 ohms. That's not good. It must be 400 ohms. Let's check between the white and the red. So it is 398 ohms. So this is our input terminal. If we check between the other two wires, it is 350 ohms. So these are the output wires, green and black. This is our output terminal, 350 and 398. So let's connect red wire. Now if we connect red wire at positive terminal, what will happen? It will reverse the connections. Let's see. First of all, I will connect it to red wire to the ground pin and white wire to the positive voltage. So this was the amazing point here. Now connect in millivolt mode, black lead at black, red lead at green, make it relative 0 because this time it don't have any fixture. Now press it. If we lift it up, it are in positive side. Let's connect now the black wire at low side, at signal low, and green wire at signal input. Let me reset it. It is now, because without fixture, now if I press it, it is weighing good. Now if we pull it up, so it is showing negative reading. When I press it, positive. When I lift it up, negative. If you see its direction on the load cell, so this is load cell, direction of movement is downside, C3 40 kg, 1.8 plus minus 1% accuracy. It don't have any part number. So this was my amazing experience with this product, this load cell, because it changed all the theory. All the standards are finished, because if we see the original, it was black and red. Red for positive excitation, black for negative excitation. And signal negative, it was white. Green was signal positive output. So here is the total change. So when I connected in this way, while testing with the ohm meter, when I connected in this way, so white wire, that is the positive output. And if you see the load cell internal structure, this is excitation. In normal cases, here is red, and sometime with sense line, we have another sense line here, black. This is green, and this one is white. But this load cell, it changed everything. This red and white are totally out. Maybe sometime you can find this issue. At that time, you will need to test the resistance. Let me remove it. Red and white. It is giving 398 ohms. And in the output, we will find 350 ohms. In the green wire, with this lead it is 263 ohms. With the white it is 310 ohms. Okay, let's consider that red wire is positive, red is positive. Let's make experiment. Green as positive signal, black as return signal. Reset. If I will now press it, it will give negative reading. When I will press it, it will give negative weight. That means the direction of movement is changed. Now we have another solution. We can swap these two wires, the signal wires, and then we can check it. Might be it will help us. Let's reset it. Now it is working good. So we can say if we connect signal positive, signal negative, this was the good condition. Here must be green and here must be white. It was the original condition. Positive excitation, negative excitation. Red, black. When we connected green at green and signal low at black, and we connected at negative supply the red wire, at positive supply white wire, it worked good. This was the one condition, that we connected white here, red here, and we connected green and black here. The display was good. When we changed the input wires, here we connected red and here we connected. At that time we needed to reverse the signal, so we connected black wire here and green wire here. At that time it is working now good. So this was my today's experience. Now we can leave it like this: positive, signal low, signal high, and the return line, that is excitation voltage. I hope so this video is informative. If it is informative, hit the like button. If you have any question, let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.